Well, I am Shoham. I work as a solution architect at Microsoft Netherlands, specifically on the app innovation and the AI side. And that's basically why this topic is pretty close to me. Um, and this is our agenda today. So RAG, Retrieval Augmented Generation, is a new kid in the block when we talk about software architecture in AI space. But as easy as that it sounds, there are a lot of nuances in this architecture pattern. And what I'm going to trying to cover in the next half an hour or so is to go through all the nuances a little bit and put a resemblance with the movie Ratatouille. I hope some of you or most of you have seen the movie where the rat is basically has a knack of cooking, loves cooking, and helps um, another person to learn and do good in cooking. So I'm going to use all sorts of references from the movie, from food, to explain what RAG is and how advanced you can go with RAGs and the different nuances to it, to be honest. So we talk about food without spices. We all know how that tastes like. How to do prep work, so chopping and assembling. I'm going to talk about how you follow a recipe. I'm going to talk about how you get Anton's approval. If you remember the movie, whoever has seen it, Anton was a food critic who used to be very, yeah, strict about writing reviews of a restaurant. Then I'm going to talk about how you master your masterpiece. So how you fine tune it, how you make sure your RAG works the way you want it to be. I'm going to talk about a few secret splice blends. So these are basically the advanced RAG patterns or the architecture patterns. And lastly, if we have time, we'll talk about a few use cases. Um, there are a lot of content here. I'm not sure how much I'm going to cover it. Put your questions in the chat. If we have time later on, we'll answer it. If not, I'll go back to the YouTube page and try to answer your questions as much as possible. So food without proper spices. So let's see. We are in second or almost a third year of large language model hype or flow or wave, whatever you want to call it. And we all have seen how hallucination became a word in our daily life. So everybody who has used ChatGPT or any sort of other AI, hallucination is a part of the thing. So you need to write your commands or instruction in such a way that the LLM understands and gives you back a proper answer. So for example, Good Friday is a holiday or not? If you ask this question to any large language model, it will give you a very generic answer. And I know in India it's a holiday, but in Netherlands, it is not a holiday. But in Microsoft, if you work as a Microsoft employee, and some banks here in Netherlands have this day as a holiday. So rest of the Netherlands not, but some of us will have a holiday on Good Friday. But if you ask the generic question to any large language model, it will give you a very generic answer. But why is that happens? You know what the T stands in GPT is the transformers. So the transformer type of model will try to finish the next sentence or a next bunch of words what you put in as an input. So if you put in as an image, you put in a text or a video, it'll try to find the next possible thing. And why is that? Because the next possible thing is what it is trained on. And mostly it is trained on a lot of things, but it'll try to find the most relevant and the high scored next piece of information to the input that you've given to. So when you get back an answer that it can be a holiday in UK, example, blah, 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 it's basically trying to generalize that whole knowledge that it is trained on, to be honest. But here comes the power of RAG. So if you, along with the question to the LLM, provide some sort of information which is very specific to your question. For example, if I search for all the holidays that are there in 2024 from our HR information, because they release this information of your yearly holidays. Every company does, to be honest. And if you add that information along with your question and then send that question to any LLM, it will properly kind of reason and give you the answer that you are looking for. So the only thing you change, you push some sort of information that is very contextual for your case before asking the question to LLM, and it will give you a proper answer. So in very short, this is what RAG is, the Retrieval Augmented Generation. But as I said in the beginning, it sounds quite simple and straightforward, but there are a lot of nuances there. But we'll go there as slowly. So technically, it has two different workflows. The top one talks about how you ingest documents, and normally these ingested documents go into a vector DB. But to be very honest, a RAG can also be based on structured data or a non-vectorized data. It's textual information. It's all about putting the context before realizing the answer from LLM. So the top part talks about how you ingest data. So normally if there's a vector database involved, you have all the documents, you create document chunks. So you make smaller pieces of documents. Then you make vectorization of those documents using an embedding model from OpenAI or Llama or Meta. And then you store those embeddings in a vector database. And vector database is nothing but a normal relational database with columns and values and everything, but it has a special column specific for vector embeddings, and that's in float 16 or 32 bits. And the second part, which is the lower part, is basically the retrieval workflow. So if you post a question, if it is a vectorized data you are searching on, it'll create the vectorized embedding of those questions, and it will do a search on the vector database. And once you have the relevant chunks retrieved from the database, you will pass on to the LLM to do the reasoning along with the question to generate an answer. So the part which retrieval is basically this, where you do a search. The augmentation is actually this, where you pass on the context along with the LLM. And generation is ultimately the generation of the answer from the LLM using all those contexts. Did I skip one slide? No, sorry. So now, chopping and assembling. What do you mean by chopping and assembling? We all know if you cannot put the whole cabbage while you're cooking any kind of dish, you need to chop it down. And every kind of cooking has a different way of chopping stuff. So if you're using this cabbage in a sandwich, maybe your slices will be bigger. If you're using it in a salad, maybe your slices will be a little bit smaller. If you're putting it in, I don't know, in some kind of a rice dish, maybe you want to chop it very thinly so that you can cook it pretty easily. So chunking is related to that. It depends on how is your search going to perform, how is your retrieval going to work out, and that's where you do need to chunk it. And there is another reason for chunking is as well. So if you have a lot of information and you want to send it to an LLM, I know Gemini has a higher context range, so you can send a whole encyclopedia, to be honest. But the amount of data you transfer over the network, the amount of money you also pay. And also it takes much time to get back the answer from LLM. So you cannot send a lot of information at the same time to a large language model. You need to make it as small as possible or as effective as possible as well to make sure the LLM performs properly. And that is loosely related to tokens. So I'm not sure how many of you know, but LLM reasons with tokens. So it accepts tokens and it generates tokens. And you can loosely say token is a word or a phrase or even a bunch of characters also. And this token every LLM has a limit of token that it can take it as an input and provide as an output. So this total token limit also comes into the picture when you basically try to chunk your documents to ingest. So remember, I'm still talking about your ingestion part. So the way you making your ingestion part smarter or efficient, the way your retrieval part will also be efficient. I also have an example here. Let me see if I can open this. So this is a free application where you can actually play around how your chunking looks like. So normally chunking can also be taught as a splitter, and there is a different kind of splitters available here. This is just a small list. There are multiple others. Just to give you an example, if I make my chunk size around 675, so this is my first chunk, this is green is in my second chunk, and the red, and so on and so forth. There's also something called an overlap, because when you're reasoning of distinctive data which were connected before, so for example, this was a whole paragraph, now I'm breaking it into different chunks, you also want to have some sort of overlap. What would the overlap gives you? The overlap gives you the piece of information that might want to flow to the next chunk of your information. And this helps when you want to have multiple search results back and you want to combine those chunks somehow to generate a reasonable information. Then it makes sense to have these kind of overlap. And this is like the old radios. I'm not sure whether you had that, but in my childhood, we used to find the FM channel on Sunday afternoon by tuning left and right and moving the antenna a little bit here and there. So this is like that. So the chunk size and the chunk overlap, there are no silver bullets for this. So you need to figure out, depending on your document, depending on your size of the document, depending on the information that you have in the document, what should be the proper chunk size, what should be the proper chunk overlap. And you need to tune this properly to have your retrieval process also better, to be honest. There are a lot of chunking libraries available, to be honest. So if you are using Llama Index or LangChain, they have a lot of libraries to help you do the chunking, so you don't have to worry about it. You just call the code and it chunks it for you. The most interesting one that I find right now is the semantic splitter. So you try to split and chunk your data depending on the semantic meaning of the data. So it is using an LLM to figure out what should be the chunk size I use. And when you hear this, you would think, okay, then that's the best chunker in the list we have. Why do we need any others? As I said before, it depends on what kind of data you're chunking. Maybe you're chunking some kind of code. Maybe you're chunking a structured HTML. You don't need semantic splitter for that. It only makes sense when you have same sort of information scattered through a lot of pages and all. I see already a question about RAG fusion and all of those things. I'll come to that. Maybe that's a good idea. So chunk is basically how you do overlapping. And this is a very naive retrieval strategy. So you have documents, you do a single chunk vector, then you do a search, you get top K, and you return. Now comes a different variation of chunking. So what you do is you create two vector databases. One has the index of the summary vector. So you summarize X number of pages from the documents and store it in a vector. And you also have the normal vector store, which does the chunking and overlapping properly. And you do a query on both of them. So once you have the first chunk retrieved from the summary vectors, you only retrieve the child vectors that are related to that summary. So you skip the search on the second vector store. And that gives you a little bit of edge, because then you are minimizing the search operation. So remember, the bigger your vector store is, the slower your search can be. Secondly, there is another thing called sentence window retrieval. So for example, this is a text from Kubernetes service automatic offer from Azure. So let's say you want to find out what are the things pre-configured in Azure Kubernetes. And you actually should get this answer back, because this is the by default configuration you get from Kubernetes. But to get a better reasoning, you can extend the context. So you can do a sentence window retrieval. So this is another way of sending the information to LLM. So not only the part that you retrieve, but also the part that is basically around it to make a better judgment call, better response. There's another strategy called parent-child. So you will have two different vector store. One vector store will have all the child leaves vectors, and another will have a parent. So think from this perspective, if your documents have different chapters and every chapter have different pages, so every page will be considered as child and leaf, and your chapter will be chunked as a parent. And once you do a search on your leaf, and let's say you get top X results back, and then you need to judge which out of this X results, which have the most parent relevance. So you pick up that parent chapter and send it to LLM and ignore the rest. So that makes your answer or reasoning very much concentrated on the chapter where the child chunks are retrieved from. There's another thing as our fusion retrieval. So you will have two different vector index. One is a normal vector index, another is a sparse n-gram. So this is basically using a different sort of vectorizing algorithm to making your documents vectorized. And what you do is after retrieving from both the vector databases, you do a reciprocal fusion. So you basically try to figure out which all documents should be on the top of the search and which all documents should be on the bottom of my search results. And then you get top X from the last results to respond to them. There are a lot more, to be honest. I've just picked up a few just to give you the feel of how complex it can get, to be honest. And there could be lots of practical challenges doing this. First of all, the number of documents that you have to index. And since you are doing it on a float data type, you need a lot of space. So space is a major concern right now with all sorts of vector databases right now. So they have, if you have a 10 GB of data, normally it will come around a terabyte when you do a vectorization of those data. And depends also on which kind of vector embedding model you are using. Right now, OpenAI gives you 1536 dimensions of vector. Do you need that amount of dimensions for your documentation? Maybe a smaller dimension would also help. So a lot of nuances are there also in that factor when you are vectorizing your data. When we create a software architecture, I would always like to follow a recipe. Like if I have a recipe, then I know these are my steps. Of course, there will be things that I can add and change and update a bit, but following a recipe is always help. And in RAG also, there is always a workflow which could be always the same, depending on the implementation of the different boxes. It depends how you end up with your RAG application. So for example, you're always reading from a document storage, files and blob, and you will publish some sort of document update events. So for example, these update events will go to somewhere, a piece of code, which will load these updates, create embeddings or vectorization of these documents or not, and then it'll add it to the vector DB along with some metadata. I'll come to the metadata part in a bit, and then you upsert all those embedding and the metadata to somewhere. Then comes a very interesting part, which I think every RAG application should think about from the very beginning, is validation or testing, what you call it in normal software development. And I call it as Anton approval. So from this phase, you want to have a this phase expression back. And how do you do it? There are a lot of frameworks available which lets you validate your RAG workflow. The one that I want to recommend right now is the RAGA's framework. It's from it's a quite used framework in doing validation within RAG applications. And what does it do? It tries to score your RAG application in 4 different variables. One is the context relevancy. So when you are retrieving data, how much extra unwanted information you're also retrieving from the database. So how much, basically how much noise is there. Context recall, do we have all the info needed that was required to answer this question? Retrieved. So your search result contains everything or not. Faithfulness, what is the accuracy of your generated answer? And answer relevancy is how relevant is the answer to the query. So basically, you're trying to minimize your hallucination and tuning your search results with 4 different parameters, basically. And it scores between 0 to 1, so you know where do you lie in all these 4 aspects. And how does Ragas do this, or any kind of validation framework does it? Is basically it asks an LLM on how the LLM is doing. Sounds like pretty funny stuff, but it's not. It creates a query and you provide a ground truth to this query. And then it uses your RAG workflow to create the answer and the context. And then it is sent to a large language model. It can be the same large language model which you're using to implement your RAG application, but it will do a scoring on all those aspects that I showed you last page, all those 4 aspects, and tells you what's the score between 0 and 1. So adding that evaluation or validation step at the end of the workflow is also what you need to have when you are implementing a RAG application. So yeah, at the end, you really want a face like this when anybody is using your RAG application. You cannot get something which is 100% perfect, but around 70 to 90 is quite good enough to achieve on a RAG application, provided you also have a feedback loop somehow implemented to it. How do you master your masterpiece is something which I call it adding metadata. So just like any other database, when you do a query, the bigger your where clause is, the faster your query would be. So for example, right now, there is a very sparse problem of adding rollback access to the vector databases. So what we can do is adding a role column along with other columns within the vector database. So when you're doing a query, not only doing a query on that, but also add the role which user is actually invoking the query. So in that case, you concentrate the query and your where clause gets tied, and you have a better performing query on a database rather than anything else. I will talk about 2 complex advanced RAG pattern. There are many more. Recently, Microsoft also released a graph RAG pattern, which is basically uses a graph SDK to create the embeddings on what it should query on. So check that out. I'll have links at the end of the thing. But the first one I want to talk about is a query transformation. What does it do? It's basically if you provide a question to the LLM or to the RAG application, it will create some sub-queries from those from that main question. So for example, if I'm trying to find out how many schools are there in New York and Philadelphia, so it will create 2 different queries. For example, how many elementary schools are there in New York and how many elementary schools in Philadelphia? And it will do a search on both of the things and get results back and send both the results back to LLM to generate an answer. So the query transformation basically gives LLM a way to minimize the hallucination or make a retrieval much better. So you are doing an efficient query here and also an efficient reasoning here in LLM part. And now I saw a question somewhere about multi-agent application, the nuances. There are a lot of nuances there, but what is basically a multi-agent application? A multi-agent application is basically you divide your RAG application in smaller parts. So there will be a agent orchestrator, which has to be connected to an LLM somehow. And depending on the query coming in, it decides which all underlying RAG applications I should invoke. And those are called as an agent. And it can be multiple agents that can be invoked, or there can be a single agent invoked. And it is also quite optional that agent also has an LLM associated with it. And you can think on this agent, you will also have a query transformation running there, or you are doing a hybrid search there, or you're doing something more dedicated. And depending on what type of vector index you're querying, your answer would be different than that. Last but not least, there are many more examples, but I put 4 major industries, to be honest. Supply chain, for example, if you're doing compliance checks, so for example, validation for all incoming orders and purchase things that are going out, you can automate that using a RAG application. If you're doing reporting, validation, procurement, B2B sales, marketing, supply chain has a lot of use cases on that part as well. Customer support on the retail is a very well-known use case, to be honest. So you have a lot of documents, a new employee comes in, he or she doesn't need to go through everything to understand and provide a customer proper support. This person can query on all the data that are there. You can use product recommender for a RAG, you can do feedback analysis with RAG, you can do marketing content with RAGs. In a finance and banking case, you can do claim processing, you can do portfolio management, transaction analytics, trend forecasting, document processing. Lots of applications of RAG if you are trying to achieve or implement it properly. But it's not that easy. There are nuances. I saw some questions in there. I didn't talk about all the nuances, but provided you basically the start architecture on how you can use it within your application. And it's an evolving topic, to be honest. In last 6-7 months, only the amount of progress we had in RAG is enormous. So keep an eye on this. Every day there's new thing coming up. Every day the vector databases are reinventing themselves. As I was saying, a vectorization of data takes a lot of space. So all major vector databases, so Quadrant, VV8, Azure AI Search, we are also trying to quantize this data. So binary quantization will make the floating point data to an integer data, and it will make the storage space smaller than previously. So it will also save your money when you're operating on a large scale RAG. There are a lot of things happening within RAG area, so keep an eye on it. And last but not least, since this is a kind of a .NET community, I wanted to talk about a little bit when you use semantic kernel to implement a RAG application, and what would the flow look like. So when a question comes in, semantic kernel vectorize the question, do a query on the vector store, and then possibly can also invoke external APIs or use a database or some sort of other functions to gather more information. And then using all those contexts from vector databases and from the external APIs, it'll create an answer and send it back. And this is all possible with, this is the semantic kernel, but you can also do it with Llama Index. You can also do it with Llama Index and also with a LangChain, to be honest. And semantic kernel has a .NET SDK, which basically quite nice. Nobody else in the AI orchestration area has a .NET SDK. With that, I always prefer that not only what I have as a knowledge to share, but also sharing how you learn more. So there are a few articles which I quite liked when I talked about complex RAG. And there are a couple of examples from Azure side which talks about how you implement GraphRag or how you implement a normal OpenAI ChatGPT style RAG application using Azure resources. If you have questions.